Welcome to Cyber Explain channel. Today we are going to discuss IAM Superpowers, Unlocking Attribute-Based Access Control, ABAC. Hey everyone, welcome back. Today, we are going to chat about something that really elevates your identity and access management game, Attribute-Based Access Control, or ABAC. If you've been working with IAM, you've probably encountered Role-Based Access Control, RBAC, which is great, but sometimes it just doesn't cut it for super dynamic environments. Think about it, what if access depends not just on who you are, but also on what device you are using, where you are, or even the time of day? That's where ABAC shines, giving you a level of control that's just not possible with simpler models. Let's explore how we got here and what makes ABAC so powerful. So, we've come a long way from just assigning permissions to individual users. Role-based access control, RBAC, was a huge step forward. It groups users into roles and then assigns permissions to those roles. This makes managing access much easier than assigning permissions one by one. For example, all developers get access to the code repositories, and all accountants get access to the financial systems. It's efficient and logical for many common scenarios. However, as our IT environments become more complex, with cloud services, mobile devices, and ever-changing business needs, RBAC can start to feel a bit rigid. We'll see why. Imagine trying to manage access for a global team where people work different shifts, use company laptops at home, or access resources from client sites. With RBAC, you might end up with a very long list of roles to cover every possible combination. For instance, you might need a developer ABAC night shift company laptop role, which quickly becomes unmanageable. Or consider a scenario where a specific resource should only be accessed during business hours. RBAC struggles to directly incorporate these kinds of real-time, environmental factors into its core logic. This is where we start wishing for more flexibility. This is where Attribute-Based Access Control, ABAC, steps in. Instead of relying solely on predefined roles, ABAC uses a set of attributes to make access decisions. Think of it like this: RBAC asks, is this user John, who is in the developer role? ABAC asks, is this request coming from John, who is in the developer role, using a company-issued laptop, from a US IP address, during Pacific Standard Time working hours, attempting to access the production DB resource? See the difference? It's all about context. We define policies that consider these various attributes to grant or deny access dynamically. Alright, let's break down what makes ABAC tick. At its heart, ABAC has three main components: attributes, policies, and policy enforcement points, PEPs. Attributes are essentially the characteristics or properties we use to describe users, resources, actions, and the environment. Policies are the rules we define that use these attributes to make access decisions. And the PEP is the gatekeeper, the component that intercepts a request and consults the policy decision point, PDP, to see if access should be granted. Attributes are the building blocks of ABAC. We can group them into several categories. First, we have user attributes, things like role, department, clearance level, or even citizenship. Then there are resource attributes, details about the data or system being accessed, like its classification, owner, or location. Environment attributes describe the context of the access request, such as the time of day, IP address, device type, or network location. And finally, action attributes describe the operation being attempted, like read, write, or delete. The richer and more diverse your attributes, the more granular your access control can be. Policies are where the magic happens in ABAC. They are the rules that dictate whether an access request should be granted or denied based on the attributes involved. A policy typically looks something like: allow access if user.department is equal to sales, and resource.type is equal to customer record, and environment.time_of_day 18 o'clock PST, and action.operation is equal to read. You can chain these conditions together to create very sophisticated rules. The beauty is that these policies can be updated without changing the underlying applications or the user's roles, offering incredible flexibility. The policy enforcement point, PEP, is the component that sits in front of the resource you are trying to protect. When a user or application tries to access something, the PEP intercepts that request. It then communicates with a policy decision point, PDP, which we often think of as the brain of the ABAC system, sending all the relevant attributes from the request. The PDP evaluates the request against the defined policies and tells the PEP whether to allow or deny access. Think of the PEP as the bouncer at a club, and the PDP as the rulebook the bouncer consults. One of the biggest advantages of ABAC is the level of fine-grained control it offers. Unlike RBAC, where you might grant broad access to a role, ABAC allows you to be extremely specific. You can grant access to a specific document for reading only, from a corporate IP address, during business hours, but deny writing access from a personal device. This granular control significantly reduces the attack surface by ensuring users only have the absolute minimum access they need for a particular task, in a specific context. Another massive win for ABAC is its flexibility. Business requirements change constantly. New applications are introduced, user roles evolve, and security threats emerge. With ABAC, you can adapt your access policies much more easily than with RBAC. Need to restrict access to a sensitive system for users in a certain geographical region during a specific holiday. You can adjust the environmental attributes in your policies without needing to create new roles or reassign users. This adaptability is crucial for staying secure in a fast-paced world. As organizations grow and their IT infrastructure expands, managing access can become a monumental task. ABAC's attribute-centric approach scales much better than role explosion scenarios in RBAC. Instead of creating hundreds or thousands of roles, you manage a collection of attributes and policies. When you add a new application or service, you define its attributes and the policies that govern its access, rather than trying to shoehorn it into existing, potentially convoluted role structures. This makes ABAC ideal for large, complex, and dynamic environments. Let's bring this to life with a practical example. Imagine a popular streaming service. They need to control who can watch what content. This isn't just about whether you are a subscriber. Access might depend on your subscription tier, basic, premium, your geographical location, content licensing, the device you are using, mobile versus smart TV, and even the time of day, age-restricted content. Trying to manage this with just roles would be a nightmare. This is a perfect use case for ABAC. For our streaming service, a user attribute could be subscription_level. A premium subscriber might get access to all content, while a basic subscriber only sees a curated selection. The policy could be, allow playback if user.subscription_level is premium. Simple enough, but this is just one piece of the puzzle. We need to layer on more context. Content licensing means that certain shows or movies are only available in specific countries. So, user.country_code or environment.ip_address_country becomes another critical attribute. The policy might look like, allow playback if user.subscription_level is premium and user.country_code in US, CA, GB. This ensures that a user in Germany can't stream content licensed exclusively for North America. Different devices might have different capabilities or security considerations. For example, maybe high-definition content is only available on smart TVs and modern browsers, not on older mobile devices. We'd use a resource.device_type attribute. A policy could be allow playback if and resource.device_type is not older_mobile_device for content_rated_as HD_only. This allows the service to optimize the user experience and manage bandwidth or performance. Finally, let's consider time _of_day. For children's programming, there might be restrictions on when it can be accessed, or for mature content, it might only be available during adult viewing hours. An environment.current_time attribute would be used. A policy could be allow playback of kids_content if and environment.current_time between 6 o'clock PST and 21 o'clock PST. This demonstrates how ABAC can enforce complex, contextual restrictions dynamically. So, a full ABAC policy for our streaming service might look conceptually like this: grant playback permission to a user for a specific piece of content if the user's subscription level is appropriate, if the content is licensed for the user's country, if the user's device type supports the content quality, and if the current time falls within allowed viewing hours for that content. This illustrates the power of combining multiple attributes to create sophisticated, context-aware access rules. Implementing ABAC isn't usually a rip and replace of your entire IAM system overnight. Often, you'll start by identifying key resources or applications that would benefit most from this dynamic control. Then, you'll need an ABAC engine or a policy decision point (PDP) that can evaluate your policies. Many modern IAM platforms, cloud services, like AWS IAM, Azure AD Conditional Access, GCP IAM, and API gateways offer ABAC capabilities or can integrate with external ABAC solutions. You'll also need a way to define and manage your attributes and policies, often through a dedicated console or API. Your ABAC system needs reliable sources for these attributes. User attributes often come from your identity provider, IDP, or HR system. Resource attributes might be stored in a CMDB, configuration management database, or directly associated with the resource itself. Environment attributes are often dynamically gathered by the PEP at the time of the request, like IP address, time. Action attributes are usually inherent to the request. Ensuring these attribute sources are accurate and synchronized is crucial for ABAC to function correctly. To define your ABAC policies, you'll typically use a policy language. Open Policy Agent, OPA, with its Rego language is a popular choice, and standards like XACML, Extensible Access Control Markup Language, are also used. These languages allow you to precisely define the conditions and logic for access. For example, using Rego, a policy might be expressed as a set of rules that evaluate to allow or deny based on the input attributes provided. While ABAC is powerful, it's not without its challenges. The primary one is complexity. Managing a large number of attributes and intricate policies can become difficult if not properly governed. Poorly written policies can lead to unintended access grants or denials. It requires a robust process for defining, testing, and updating policies. Think of it like managing a complex legal contract. You need to be precise and thorough. Every access request now involves a complex evaluation against multiple attributes and policies. This can potentially introduce latency compared to simpler RBAC checks. For high-throughput systems, optimizing the PDP and ensuring efficient attribute retrieval is critical. Caching, efficient policy evaluation engines, and well-designed attribute sources are key to mitigating performance concerns. Implementing ABAC often requires integrating various components: your identity provider, attribute sources, the policy decision point, and the policy enforcement points. The tooling landscape can vary, and ensuring seamless integration between these different systems might require custom development or careful selection of vendor solutions. It's about building an ecosystem that works together harmoniously. It's not always an either-or situation. Many organizations use a hybrid approach. RBAC can still be excellent for broad, foundational access control. For example, all employees get access to the internal network via their employee role. Then, ABAC can layer on top for more dynamic, context-specific controls. Perhaps only employees in the finance department can access the payroll_system during business hours from a corporate network segment. This combines the simplicity of RBAC with the power of ABAC. ABAC represents a significant evolution in how we manage access. It moves us away from static, role-based assignments towards dynamic, context-aware decision-making. This is crucial as our digital environments become more distributed, heterogeneous, and interconnected. By embracing ABAC, organizations can build more resilient, adaptable, and secure systems that can truly handle the complexities of modern business and user behavior. So, to wrap up our discussion on ABAC, remember these key points. It moves beyond roles to use attributes like user, resource, environment, and action for access decisions. This provides unparalleled fine-grained control, flexibility, and scalability, making it ideal for complex scenarios like our streaming service example. While it introduces complexity, with good governance and the right tools, ABAC can be a game-changer for your organization's security posture. It's about making access decisions smarter, not just stricter. When you are first exploring ABAC, don't try to boil the ocean. Pick one or two high-value use cases where RBAC is falling short. This could be a critical application with complex licensing requirements or a set of privileged operations. Implement ABAC for that specific scenario, learn from it, and then gradually expand. This iterative approach helps you manage the complexity and demonstrate value early on. Your ABAC system is only as good as the attributes it has available. Invest time in defining clear, consistent, and reliable sources for your attributes. This means working with your HR system, your device management tools, your network infrastructure, and your application owners. Automate attribute updates wherever possible. If an attribute source is unreliable or outdated, your ABAC policies will make incorrect decisions. Just like infrastructure, your ABAC policies should be treated as code. Use version control, have testing environments, and implement review processes before deploying changes. This policy as code approach ensures that your policies are auditable, repeatable, and less prone to errors. It also makes collaboration between security, development, and operations teams much smoother. Watch out for creating God policies that try to do too much. Break down your logic into smaller, manageable policies. Also, avoid overly complex attribute names or values that are hard to understand. And critically, ensure your PEPs are correctly configured to capture all necessary attributes for your policies to work. Debugging ABAC issues often means tracing the attributes collected versus what the policy expected. Interestingly, AI and machine learning can play a role in ABAC. ML can help identify patterns in user behavior or resource access that might suggest new attributes or policy refinements. For instance, if an ML model detects a user is consistently accessing sensitive data outside of normal patterns, that behavior itself could become an attribute fed into an ABAC policy to restrict access, enhancing security dynamically. Cloud-native applications, microservices, and serverless architectures thrive on ABAC. These environments are highly dynamic, with resources and services spinning up and down constantly. ABAC, especially when integrated with cloud provider IAM services, like AWS IAM, Azure AD conditional access, provides the granular, context-aware controls needed to manage access effectively in these ephemeral and distributed systems. Imagine a policy in AWS, allow access to S3 bucket confidential data if user.role is equal to data_analyst and environment.aws_region is equal to us east 1 and resource.data_classification is equal to confidential and action.operation is equal to get object. This policy uses user, environment, resource, and action attributes, leveraging AWS IAM's ability to define such conditions. While AWS IAM often uses conditions similar to ABAC attributes, dedicated ABAC engines offer even more advanced policy expression capabilities. API gateways are fantastic places to enforce ABAC policies. When an API request comes in, the gateway can inspect the request headers, user info, API keys, query parameters, and even the source IP address. It can then call an ABAC PDP to decide if the API endpoint is accessible based on these attributes before forwarding the request to the backend service. This protects your backend services effectively. With ABAC, logging becomes even more critical. You need to log not just who accessed what but also why they were allowed or denied. This means your logs should capture the attributes that were evaluated for each access decision. This is invaluable for troubleshooting, incident investigation, and proving compliance. Imagine a breach. You'd want to see that a user was denied access because their device was unmanaged, for example. So, that's our deep dive into attribute-based access control. It's a powerful evolution from RBAC, enabling much more dynamic, flexible, and scalable security. While it brings its own complexities, the ability to control access based on context, the who, what, where, and when, is invaluable in today's digital landscape. Start exploring how ABAC can empower your organization's security posture. Thanks for joining. Thanks for watching. Subscribe to the CyberExplain channel. See you on the next video.